Hello and welcome to this video. I want us to learn how to convert a complex number into its polar form. So if I have a complex number z is equals to a plus bi. So this is the rectangular form. We call this form the rectangular form of a complex number. So to convert a complex number into its polar form, we're going to make it be in this form. So r cos theta plus I sin theta. So this is the polar form of a complex number. So let's have an example. If we have a complex number, z is equals to 3 plus 4i. So this complex number is in its polar form, in its rectangular form. So I want us to convert it into its polar form. So we need to get the value of r, and the value of theta. So r is the modulus of this complex number. So the first thing is to get the modulus of this complex number. In the last video we learned how to find the modulus of a complex number, and if you happen never to watch that video, you can follow the link in the description box. So let's find the modulus of this number. So the modulus is going to be 3 squared plus 4 squared, and then find the square root. So this is going to be 9 plus 16, and then the square root, and this is going to be the root of 25, which is equal to 5. So the value of r is 5. So let's now work out the value of theta. Now let's try to map this complex number on the complex plane. We have this is the real axis and the imaginary axis. So we're going to move 3 units on the real axis, so 1, 2, 3, and then 4 units on the imaginary axis, so 1, 2, 3, 4. So this is a complex number. So let's have it that way. So we have 3 units here and 4 units here, and then the modulus is 5 units. So the value of theta is this one. Let me use a different color. This angle from all the way from down here to up here, the value of that angle is theta. So we are going to calculate the value of theta. We can use the SOHCAHTOA method because we have all the 3 values of these lines. So we can use sine, cosine, or tangent, but I want us to major on the tangent because it makes our work easier. You don't have to draw or to represent all this information on the complex plane. I will show you how to find the value of theta without having to draw or to represent a complex number on the complex plane. So tan theta, so this is theta, is going to be opposite the value of the opposite line, which is 4, over the adjacent line, that is 3. Okay, so you can use your calculators to find the value of theta, and theta is going to be, so the value of theta is 53.1 degrees, you just have to find the tan inverse of 4/3. So that is the value of theta. So as I said, we use the trigonometric identity tan or tangent to make our work easier. So you see, let's go back to our complex number here. So finding the value of theta, we just have to find the tan inverse of y. This is y, or the coefficient of the complex or the imaginary number, that is 4, and then divide by 3, which is the real number. So, and that is going to make our work easier. We don't have to draw all this to represent all this information on a complex number so that we can get the value of theta. So now we are going to write it in polar form. So our formula was r and then cos theta plus I sin theta. So the value of r is 5, and then cos 53.1 plus I sin 53.1, and that is the polar form of that complex number. Let's look at another example. If we have a complex number, z is equal to 5 minus, okay, let's have negative 5 plus 12i. Okay, negative 5 plus 12i. So let's first of all find the value of r, which is the modulus of our complex number. So as we said, we take negative 5, we square it, and then 12, we square it, and then find the square root of the whole thing. So it's going to be 25 plus 12 squared is 144, and this is going to be the root of 169, which is equal to 13. So this means that the modulus of this complex number is equal to 13. So I want us now to find the value of theta. So let me represent this complex number on the complex plane so that we can get to understand in a better way. So that is the complex plane. So we have, we're going to move negative 5 units on the real axis. Negative 5 units means that we're going to move towards the left 5 units. So 1, 2, 3, 4, 5. And then on the imaginary axis, we're going to move 12 units. So we're going to move 12 units upwards. So I can say the space is not enough, but maybe we can just assume that this is the point 12i. So our complex number is going to be mapped somewhere here. So the modulus that we have represented as 13 units is going to be that one. And we moved to the left 5 units and 12 units on the imaginary axis. So, and this is 13 units. So the angle that we are interested in is the whole of this angle from down here all the way to here. The whole of this angle. That is the value of theta. So when we use our trigonometric identities, we'll find the value of this angle here. So once we find the value of this angle, we'll then subtract it from 180 to get the value of the remaining angle. Okay, from here, okay, let me use a different color. The whole of this is 180 degrees, but we are interested in the value of this angle from here to here. But we can use the trigonometric identities to find the value of this small angle here. This means that to find the value of the remaining angle, we'll subtract it from 180. So let's go ahead and use the trigonometric identities to find the value of theta. So as I told you, let's use the trigonometric identity tangent. So the value of theta is going to be the tan inverse of 12 all over 5. So I prefer to assume the negative sign. The negative is just going to show us or will just help us in mapping this complex number, showing us on which quadrant it is. So for this one, it is in the second quadrant. So I prefer that we ignore the negative sign and then we just use it to determine in which quadrant the complex number is. So go ahead and pick up your calculators and find the value of theta. So this is going to be 67.4 degrees. But that is the value of this small angle here. This one. This is 67.4. But we are interested in the angle from here to here. So as I said, we need to subtract 67.4 from 180. So 180 minus 67.4 degrees. So this is going to be 112.6 degrees. So we have now the value of theta. So this is the one that we are interested in, 112.6 degrees. So we now go back to the polar form of this complex number. So we have r, and then we have cos theta plus I sin theta. So the value of r, which is 13, and then we multiply by the cosine 112.6 plus I sin 112.6, and that is the polar form of this complex number. So I see I'm running out of time. I'm going to create another video of how we can represent complex number in polar form so that we can get to understand even better. So let's meet in the next video.